Alcocer, can you please start your presentation? Of course. I am now going to be referring to the continuation of what Engineer Bautista mentioned, the seismic refitting of physical education infrastructure. This methodology helped INIFED and the efforts by Dr. Renato Berron to have knowledge on how to refit a school. This information was non-existent in our country. And going back to the question that was asked to Rene Bautista, whether this can be applied to all structures, and the answer is yes. Yet, in case of heritage buildings, then you need to refer to other guidelines. But for buildings, hospitals, schools, commercial buildings, this guide can be used for those. I would like to remind you, first of all, the integrated cycle of risk. We see that we have the evaluation 1 and 2 for aiding or helping if necessary. Once we have defined that there is a refitting process needed, which is going to be the focus of this process, then we would need to do an evaluation to determine how much will this refitting process cover according to the rules and regulations. And using the same slide as Ruben, I can show you that this is a level 3 methodology applied for the refitting of buildings. And this is applied weeks or months after an earthquake, depending on whether we have the resources to carry out the refitting. This would be the 4th document of this series that we have been discussing, the technical refitting methodology. This guideline is targeting project managers, builders, directors, and co-responsible parties and owners, not just of public infrastructure, but private schools, to evaluate, analyze, design, construct, review, and supervise the refitting process. It supports the constructor and supervisor and allows the owner of the school to know how the school must be refitted. It was thought to use many specialists according to the damage in the building. And even if there are no damages and it's simply applied to reinforce the structure, it is convenient to have colleagues from soil mechanics. This methodology is mandatory for the public national system or the education and for the building of new schools and the rehabilitation and refitting processes of these schools, as well as private schools. This guide is designed to be used as a complement of the local regulation. This in Mexico City is complemented by the rules and regulation of constructions, and in other states it will have to be a complement to local regulations and complementary technical standards. If they don't exist, they need to comply with the minimums established in the Complementary Technical Standards 2017, which are the standards that we have in general. In this guide, we establish recommendations depending on the type of building that is being refitted. When we recommend the possible solutions that we can develop to refit a concrete building or steel structures We also discussed the refitting process of bearing walls and masonry walls. These techniques have been used in different levels throughout the country, but they kickstart the technical guide. They include what a report must have, and the executive project must include, to get rid of every ambiguity about what must an executive project include, or a refuting process. And this can be applied for any other building that is going to be refitted. It includes a description of the different refitting strategies that we can apply, such as the modification of structural components, their repair, the elimination or mitigation of irregularities, rigidity of structures, the elimination of problems caused between buildings, and the reduction of reactive mass, etc. For each one of these strategies, we ask people to follow a series of stages to assess the building, which you can see in this slide, which starts with the investigation of the characteristics and the condition of the structure. In case we don't have blueprints and calculation memory, we have moved forward a lot at INIFED with the DNA of the structures, because they will be more useful to have a more solid evaluation of their characteristics. We must determine the cause of the damage, not because of earthquakes. Sometimes our schools, because of lack of maintenance, because of corrosion, they can have damages. We select solutions for refitting. And the fourth stage is the proper development of these refitting techniques. In this guide, we have specific sections about the different aspects of the assessment, degradation of materials, how to consider the loss of the cross-sectionality of a bar, which would be deteriorating the resistance of a structural element. Talking about the damage, we specify how must a survey be done, how must we record it, classify it, and what type of photographs we need to take. This was included to answer one of the concerns on the quality of information and competence and information, which was very heterogeneous in terms of schools and other types of buildings. We also have the determinations for mechanical features. First, we determine if we have access to calculation memories, blueprints. If we don't, we can use historical data pointing out concrete resistance for structures, and also elasticity measurements for steel, and also physical tests. For example, concrete cores or test for corrosion. Now, the guide signals that we can't use non-destructive methods to determine mechanical properties. We can't use an accelerometer to measure the resistance of the concrete. We can use it to compare the uniformity of concrete in an element or between elements, but not to derive the resistance of the concrete. We must take concrete cores, and if we can't, we need to use historical data, which is available data. Here we have an example of the table included in the technical guide. And as you can see, any structure built between the 1900s and 1987, we're talking about 90 kilograms per square centimeter. And again, we can have some tests if we have concrete cores. The most extensive chapter of the guide is chapter 6, where we talk about each one of the refitting techniques. 16, or rather 15, well, because the first section refers to the scope of the chapter, and for each one of these 15 techniques, we have a consistent description pointing out the possible deficiencies that we can correct with these techniques, how these design demands must be corrected, the internal design momentums and strengths, and the demands and capabilities, rigidity and deformation, a description of the technique, and the different supervisions that we need to take. We need to point out that many of these requirements are not the same as the ones that come for new structures, because these cannot be reinforced in the same way as in these old buildings. It is sometimes physically impossible to do jacketing in a column. That's why we ask for these braces and supports to be different. And this is, for example, the jacketing of columns and concrete walls technique that increases rigidity, and it relates to adding a concrete layer to existing elements. The guide has drawings like the one you see here. We have used different colors to stress the longitudinal reinforcement, and you can see the jacketed column where we use closed braces, but also braces or supports of different pieces. We also mentioned the endings of each one of the framing that needs to be done, and echoing the question from the previous presentation, this is sometimes ignored in some constructions. We also add photographs of what we consider a good refitting practice. For example, the proper treatment of the surface of a column. At times we have seen jacketing of columns with no treatment in the surface. Sometimes we see this, and we have also seen jackets. These are photographs of buildings in Mexico City, not necessarily schools, where you see that the hooks of these rods are bent 90 degrees, and if this column is subjected to a movement, these braces, these containment will not work as intended. We also place photographs that show good practices of these details. For example, the hooks 170 degrees, and some of these properly placed. Now, we need to also stress the quality of the pouring of concrete. The air to come out and to not become trapped as it rises up, because if we completely seal air, it will not only have an improper finish, but it will leave holes that are important in terms of rigidity and ductility. Now, we also have a section dedicated to the obligations and responsibilities of the builder. What we did here was to try to gather the best practices that we have seen at INIFED in different matters. We first state that the constructor is responsible to build and execute the project to refit the building, and the constructor has the obligation of facilitating all the resources for the supervision and tests, load test, and the assurance of quality. And the constructor must comply with the specific requirements to do these bracing. And this is important because in refitting projects, we frequently take away structural elements that have the ability to withstand earthquakes, and thus we leave these buildings more vulnerable to side loads. And that is why the constructor must pay attention to framing and bracing the building as the project designer uh, planned. If this doesn't take place, it will important to get someone who knows the bracing techniques that are necessary, and also they will need to comply with the specific requirements pointed out for the supervision, testing, construction, and quality assurance. As we all know, a project is a chain of different steps that need to be taken as stated in the project, and construction is no exception. In the case of structures that are going to be refitted, the role of quality assurance and material quality is paramount. If we're talking about the joints of new concrete and anchors, we need to put epoxy, but we need to use normalized epoxy or standardized epoxy. Number one. Number two, we need to use rods or steel balls that also comply with the Mexican applicable standards. If not, the epoxy will fail, the reinforcement concrete will fail, and eventually the joint will fail between the new structure and the old structure. That's why we emphasize the technical guide to comply with these standardization processes. We have talked about the bracing. It is important to point out the parts that will require bracing and securing in the project, and the stages that will be followed to refit the structure, whether we're going to be taking away load bearing walls. In that case, of course, we'll have to brace the structure in order to not have an improper effect on the structure once we take out those walls. We also stress the importance of supervision. We have a series of requirements in regards to supervision for each one of these techniques. And we have, in general terms, supervision regarding material, then supervision for different processes, the pouring of concrete, the placement of anchors, the compacting of refitting materials, etc. For example, we've seen in some constructions that some additives are used that are not the proper ones. Pebbles from rivers or sand that is not properly sifted, or water that might have materials that could affect the concrete. And It is not enough to comply with the calendar or the timetable or the budget, which we must also make sure that the quality and the execution of the safety is proper enough as stated in the project. This is another image similar to Ruben's, where we show the great array of very enthusiastic young people who have been working on these guide, and we will finally like to mention that this document is going to be available tomorrow, and this document is an evolution of the document that is already available at the Construction Safety Institute of Mexico City's website, which was a first document made by Dr. Barron. This document includes a wider set of descriptions and photographs of many of these techniques, and we consider that this document is a reference document that is very valuable, not just for refitting schools, but in general to refit buildings in Mexico. We have already mentioned that it will continue to evolve to a standard level in a few months. Uh, in the meantime, this document is mandatory for school refitting in the country, and this is my presentation. I am available for questions.
Thank you, doctor. We do have time for 3 minutes, and these are questions that have to do with the foundation repair criteria. And are there any guidelines on retrofitting or rehab repair of foundations? Yes, we do have a chapter on that. And generally, we talk about the different types of foundations and the reinforcement relating everything to the structural elements and their retrofitting. For instance, we have to expand a few of the elements, and this means mixing new and old concrete. And we talk about other chapters when we talk about placing the anchor, and we talk about many other elements to be used this way. We've included considerations on foundations leveling process. We have various expressions that have been reviewed by Dr. Alberto Cuevas. This is a document reviewed by a dozen of colleagues, practitioners, engineers, architects who made many suggestions to enhance the guide. So we've had the participation of many people reviewing all this work, and they are really helping us through their suggestions. Thank you. There's another question on a rehab mechanism in schools after 1985. This has to do with pre-tensioning or post-tensioned cables. Yes. Is there anything you can use to determine the capacity of structures reinforced with cables? In the guide, we have a specific clause, a fraction on retrofitting of schools with post-tense cables. And we look into the steps to follow in the design and the construction. There's more literature on this with Jose Maria Ribó and Ingeniero Arce also talking about this, but we do have this as part of the techniques, yes. Thank you very much, doctor. Very well. We do not have more time for the Q&A session. Thank you, Dr. Alcocer, for your participation.